Okay, so I think we'll get started right about now.
Yeah.
Looks like 1:46.
Okay.
As good as time as any.
As good as time as any. So obviously, unless none of you can read, today we're going to be talking about Android Auto. And just to introduce ourselves, my name is Henry Newton-Dunn, and I'm one of the UX leads for Android Auto.
And I'm Greg Neiswander, and I'm the research lead for Android Auto.
So today we're going to talk about some of the design thinking behind Android Auto, and we think of it as a platform, and time permitting, we're going to talk about some of its implications.
Right. So, for those who don't know, Android Auto is basically bringing Android into the car. So you connect your phone, and it gives you an Android experience directly on your vehicle's display. This means that you get the apps and the functionality that you're looking for from your phone, but you're getting it directly in your car's display as opposed to holding your phone. So what does that mean? Well, we have different services. So we have the home page, which is very similar to Google Now. So it's giving you suggestions and what things are currently active. We have, of course, phone. So you can make phone calls in the car. That's very important. And we have messaging as well. That's voice-based. We have Google Maps. So we have mapping. So you can get where you need to go. That's very important while driving as well. And we have media. So this is open to third-party development as well, so that third-party developers can come into Android Auto if you have a media-based app. And so we have lots of different media apps today, including like Spotify and those types, and Google Play Music, of course, as well.
Yeah, and just to connect, to make the connection is very, very simple. As you can see, I have drawn a USB cable. And, but I think that the interesting thing is that actually the phone is powering the entire experience. And so in many ways, the infotainment screen within the car is kind of acting like a second monitor. And we call this system like a projected system. Sorry, we got microphone awkwardness going on here. So the other thing as well, obviously all of you are probably aware of Google and Android. And I think that one of the things that's kind of interesting to point out is that Android creates platforms at scale. So we have enormous kind of like user base. So I think at last count, or last time we publicly kind of gave the figures out, it was something like 1.4 billion users. So everything that we do carries a certain amount of stress with it, I might add. Also, one of the other things, obviously, when we think about Android, predominantly we think about Android being an operating system for mobile phones and handsets and tablets and so on. But we are actually diversifying and seeing Android as a platform that can go into other types of device or form factor. So obviously we're talking about Android Auto today, but there's also an Android TV solution, and we're also kind of getting into the wearable space with Android Wear that you can see pictured here.
Right. Okay, so, and when we're going into these new spaces, we have to take the context and the environment into consideration. So when we think about driving in Android Auto, we think about traffic and people sitting in their car. And it's a problem because people are busier than ever. Traffic is very bad, as we all know, at least those who live in Seattle or San Francisco or wherever it might be. So we sit in our car a lot, we get bored, and we have other things that we need to attend to. And so that often leads us to start to engage in activities on our phone that we shouldn't necessarily be doing. And it's a problem because it's dangerous. So this is from NHTSA. They ran a study and they found that the average single glance of your eyes off the road when you're sending a text is 5 seconds. So that's 5 seconds that your eyes are off the road. And when you're traveling at highway speeds, that's the equivalent of basically going the length of a football field without looking up once. So it gets really, really dangerous. Now you couple that with we all tend to overestimate our driving abilities. And it's not just saying it, the research actually backs it up, that we tend to do this. So we all think we're better than average drivers. And on the flip side, we also underestimate the dangers of driving and the situations that we put ourselves into. So it leads to a bad mix where you're overconfident, you don't understand the dangers, and this is when crashes happen and bad things occur. And the problem is that when you're talking about driving, it's not just, if you do something stupid, you're not just putting yourself at risk, but you're putting people around you at risk as well. So
I was going to say, one of the things I love about this slide is it's something like 93% of Americans think that they're above average drivers, which is insane, which means that you're all above average. It's brilliant. So this is probably the most obvious slide we're going to have in our deck, which is a phone is not a car, right? But I think it would be really easy for us in many ways. Just say, hey, we've got Android and operating system on a phone. Let's just put it in a car. And I'm just going to put you all at ease and just say that is exactly what we have not done and all we will ever do.
Right. So it's the takeaway though is that it's not necessarily the phone's fault. The phone isn't the problem. It's the interface. So it's what we're displaying, how we're displaying it, and how we're interacting with the phone or the content on the phone.
So that kind of leads us to this idea of design for driving. So we have like a few catchphrases that we kind of use within the team, and this is one of them. So we talk about this thing, say, has this thing been designed for driving? And we have a number of different ways of thinking about what design for driving means, but perhaps the easiest one is to, if you just go next slide, you can see here that we have two tasks going on, right, within the car. We have the primary task, which is driving, and we have the secondary task, which is basically everything else. And I think that many of us, probably in the room, come from a background of doing design for mobile devices or interfaces on computers and so on. And what's interesting is that normally that's the primary task. We're trying to find out how to make something sticky, attention-grabbing. We want to make something where we hold people within an experience. But actually, this is, Android Auto is exactly the opposite. It's something where we want it just to be highly glanceable and only using it when you really need to, because everything that is not driving is in fact distraction.
Right. So let's talk about distraction a little bit. Distraction can be broken down into different ways. There's a lot of ways we can split it. Fundamentally, the easiest is to split it into 3 different categories. So you start out with visual distraction. This is very simple, right? So it's whenever your eyes are off the roadway or off the driving task. So obviously when we have a competing interface inside the car, we need to minimize that visual distraction to keep the eyes back on the road. Because we know when eyes aren't on the road, people don't drive well. It's kind of required. But there's other kinds of distractions. So manual is another kind, right? So if your hand's off the wheel, we have to design the interface with respect to how big are the tap targets, how easy is it to hit, how much do you have to fumble around with stuff. So we want to keep, as much as we can as well, the hands back on the wheel. And then we have cognitive. And cognitive is super, super challenging. So this is when your mind isn't thinking about driving. So it's a bit weird because you can be staring at the roadway and you can be driving, but you're not actively thinking about what you're doing. So we also want to pay attention to cognitive and basically reduce the amount of mental load that you have to use when using Android Auto to, so that you can push those resources back onto the activity of driving.
So yeah, that was just actually one thing I was going to say about cognitive distraction. So one thing that's kind of interesting about cognitive distraction is we can think about it a little bit like the way that we load and unload or switch apps on a phone. So when we're switching apps, obviously it has to unload and reload, and that takes time. And actually it turns out that it's the same thing mentally is happening as well, that we are unloading one mental model, and then we're reloading another mental model. And that's time that you're not actually driving in the car.
Right. And so when you're inside the car and you're doing something other than driving, whatever it is, it has some element of all the different forms of distraction. So if we take something as simple as rolling up the window, the activity of moving your hand off the wheel would be manual distraction. If you have to look at where the button is, that's going to be some element of visual distraction. And then if you have to use some mental processes to think about, okay, which way do I actually have to pull for it to go up, that's some level of cognitive load that you have to impose to complete the task. So no matter what the task is inside the car, it has all of these elements. And so we have to be really careful when we're designing any interaction because it's going to take, again, all forms of distraction. The big thing to understand, though, is we can't eliminate distraction altogether. Every time you step in the car and you do something other than driving, even if it's talking to the person next to you, that's distracting. So we can't fully eliminate distraction. But we can do our part through responsible design to try and mitigate distraction and try and reduce those loads as much as possible.
Yeah, and obviously, as I alluded to before, that means that we just need to fundamentally rethink everything. How buttons work, how lists scroll, how the system is fundamentally organized. We can't take anything for granted because it's a completely different space from all the other design spaces that we've had to design for before. And we have a number of, again, I'm going to get into these catchphrasey things, right? Sorry about that. And we have a number of ways of kind of doing that. And this is, again, one of the things that we talk about, within the system that we've created. And we talk about it being biased towards action. So there is a reason why I've put a crappy illustration of, this is actually my car stereo, tape cassette one. It's wonderful with radio buttons. And there are some interesting properties with this that I'll get into a second. But let's just think first about what it is to play a piece of music on a mobile phone, right? So if I have my mobile phone, I can open up my application of choice, and I'm presented with a few categories, and I'll scroll through the categories, and oh, that sounds good. And then I'll have another sub-menu and scroll through another set of list of things, maybe another list of things, and then eventually I'll get to a page where I can see this is the song or the piece of music or the album I want to play, and I hit play. So there's a whole load of noodling around that goes on before I actually got any music out of the phone at all. But in a car, that's just not appropriate. So we need to turn all of those models that we're used to kind of dealing with, we need to turn them inside out. So actually, the first thing that comes out is the music. So obviously with this kind of, my cassette player thing, I put the cassette into the hole, and music comes out magically. It's amazing. And if I hit the radio buttons, a radio station will play. And one of the things that's kind of interesting about that is normally that will do. Right? When you're driving, your tolerances for what is acceptable are actually much lower because you don't want to have to spend time searching for something else.
Right. Did you have anything else to add?
No, that was
okay.
it.
Okay. Another catchphrase: simple and predictable. So this seems pretty obvious, right? But it's really important. So as Henry was alluding to, we want to make the interface as bone simple as possible, and that means avoiding, as much as we can, hierarchical structures. It's a difficult one to say. But deeply, rooted menu structures where you have to go item after item after item after item and scrolling. It gets really complex, and you can get lost in those menu structures. So we try and keep it as lightweight as possible so that you can surface main actions as quickly as possible, and thus making it simple and hopefully predictable as well.
I think it's also just quickly important to point out that we also have to avoid complex modal states, because also that can be very difficult for people to remember which state the system is in. So I put the system in one state, I start taking a critical turn, doing something, then I have to come back to it, and I can't remember what the state is or how to get out of that state. Again, we're trying to make everything as flat as possible.
Right. But that doesn't, it gets difficult, right? Because if you have maybe that one song that you want to play or that one artist you want to listen to or whatever it might be, visual interaction might not be the key there to get to. If you have 200 artists that you're trying to sort through, it can be really hard to find that one song. And so that's where voice comes in to help alleviate some of those issues. So as much as we can in Android Auto, the goal is to make voice a predominant interaction inside the system. That way, instead of using, having to go through tap, 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 tap to find what you're looking for, you can simply make a command. And so having natural voice interaction is really, really key, and global interaction, so I don't have to be in any certain area to be able to make a command. You can make global commands anywhere. It's really important to try and reduce, again, the visual distraction.
Sorry, I keep on butting in. I'm a bad co-presenter. The other thing I was going to say, I think that's important about voice is to also recognize that it's not a cure-all, right? You can't just say, oh, we're just going to make the whole system controlled by voice. It's going to be brilliant. We can use it for everything. Because actually there are a lot of situations where actually voice isn't very good. So a good example of that is perhaps if you go to a restaurant like this evening and, and the server comes over to your table and says, here are the 10 specials. By the time he or she's got to number 10, can you really remember number 1? And that's because you're having to mentally model that whole list. And again, we get back to cognitive load.
Yep.
You're putting too much strain cognitively on the driver.
Cool. We lost a slide.
We've lost a slide.
Okay, so we're going to ad lib.
Yeah.
We're missing one slide.
I can go through.
This is close enough. Yeah.
So we also had a slide that talked about typography, tap targets, and contrast levels.
Yeah.
So those are the other things that we have to think about. And I think, well, of course, when we're laying something out on a mobile system, right? When we're doing just standard interaction design, we think about all of those things. But when we're thinking about it within the driving space, it's completely different because everything suddenly becomes critical. So it's like how legible is something? Like how far away is, how legible is the font? How far away is the screen from the driver? What is the pixel density of those screens? All of those things become highly critical. And they're things that we have to think about and control in very careful ways. And also things like tap targets. It's not just good enough to say, we're going to put giant tap targets on the screen for touch screens. We also have to think about where those tap targets are in relation to things like the edge of the screen. So we know that, for example, tap targets near the edges of a screen are easier to hit than kind of like tap targets nearer the center, because users can often do kind of like they can often anchor their hands on the edge of the screen and stuff like that.
Yeah.
And then contrast is also completely different from the contrast kind of situation that we have to deal with on a mobile phone, again, because it's critical, and we have to make sure that the screen is legible under any kind of lighting condition. So, when we're thinking about contrast, within this kind of space, it's contrast, so I can see which is the clickable thing, or I want to make sure that I've got a highlight color, or whatever it is. But we don't think about things like glare, because I can just solve glare by tilting my phone slightly to the side. But when you're in a car, that's not true at all, right? The screen is immovable, and the sun is coming from the side, and you have a huge amount of glare. Yeah. You still have to be able to read the screen. So, yeah.
Yeah, so it's really, really important. And we're really interested in this topic, everything legibility, readability. And we, on our research team, we just don't have time to try and figure all of this out. But the good thing is other people have already been trying to figure this out for years ahead of us. So MIT Age Lab, Monotype, they've been doing some of this research looking at the legibility of glanceable interfaces. And it's really pretty amazing because what you find is little changes, little tweaks in the font styles or the font weights can actually have significant impact on the glance times and the readability. So we're interested. So we partnered up with MIT and Monotype to do collaborative research. So we're working with them to do research to better understand this field because it's ultimately you find if you get into this, it's super complicated. And the deeper you dig, the more you understand there's more and more and more to dig. So it's almost this endless amount of topics that we're coming up with that we want answers on. But yeah, it's really, really fun and interesting.
Yeah, so another thing is we talk about the system being kind of knowable and familiar. So this is another kind of catchphrase we use. And when we talk about knowable and familiar, we're talking about not on an application-by-application basis, but we're thinking about it as a whole, right? How is a system holistically knowable and familiar? And this kind of relates back to the thing I was talking about with the cognitive stuff earlier, and saying that when we're kind of moving from one application to another and we're switching mental models, that takes time and that's distracting. But sorry, that was distracting. And no, it doesn't matter. Anyway, and but so our thought was, well, if if we want to make a system and we want to mitigate or minimize the distraction as much as possible, is it possible for us to have a single mental model for all the different types of applications that exist within the system? And again, of course, that's completely at odds with everything that we've learned from mobile phone and like tablet systems. But we thought it was really important to do within the car or the driving space. So we have this single mental model, and it's very, very simple. This is just a kind of exploded view of one of the music or the media player. And you can see that we pretty much, throughout the whole system, we have a menu kind of like button in the like the top left. And when you open that menu drawer, it's not just, oh, here's the menu, and you can just put random stuff in there. We try to actually control what level of functionality and what types of functions go in there, so that they're a similarly appropriate level, whatever kind of like driving, whatever activity you're in, whether it's navigation or communication. And then, as Greg mentioned earlier, sorry, I'm going to go back. As Greg mentioned earlier, we have the microphone in the top right, which is globally accessible. So again, it's very simple. If I want to access the mic, it can just be a muscle memory thing. I don't have to think, oh, I'm in this application and the mic is here, or I'm in that application and the mic is there. It's as self-similar as possible. And then obviously we just have that activity bar, which apparently ends with B on this projector. But it says bar here. But anyway, and then the activity bar allows us to switch through those critical activities, again, very, very easily. And you can see that we've placed it along the bottom edge so that users are easily able to anchor and get to those points kind of easily. And then just on a typical design thing, I'm not sure if you can see it with the contrast levels of the projector, but there's a baseline grid. And we've tried to align everything as much as possible, not just because we want to make it look pretty, but because, again, we want to make sure that when you're looking for things and you're looking for those cutting lines and you're looking to see, where you're reading the typography, it's a place that your eye is naturally falling to throughout the whole system, because we've tried to, again, organize it in this knowable and familiar way. So this is just some examples. Actually, these are kind of early sketches. So the only real app here is this one, which is Google Play Music. This is in a night mode. But as I can flick through these different, kind of apparently different music services, you can see that pretty much they all look the same. And the reason that they look the same is that we want the play button always to be in the same place. We want rewind and fast forward to always be in the same place. And if there's things like thumbs up and thumbs down, as much as possible, we want those to be in the same place as well. So it's this kind of, again, it's totally different from all of the regular application development and stuff that we're used to. But I think it's really, really important to make a system that people can actually use while they're driving in a reasonable way.
Yep. And then another thing we have to do is we have to actually integrate it into the car, right? So it actually has to connect somehow. And so we talk about natural integration as much as we can. And what does that mean? Well, the driver, when they step into the car, they already have some pre-existing knowledge of how to use the system in the car. They already know where some of the buttons are, maybe not all of them, and they know what at least a handful of those buttons do. So when we integrate in, we want to try and take over some of those buttons that make sense, at least, as much as possible. So we work very closely on a per manufacturer by manufacturer basis to work through some of those decisions about what buttons can we take over. So when I reach on my steering wheel for the push to talk button or the voice button, it's going to work for Android Auto as well, or the volume button or the skip track, previous track button. So that way, it's more of a natural extension into the car as opposed to this one-off feeling. Yeah. And it gets really, really difficult because for those who have stepped into or gone car shopping recently within the past couple of years, you'll find that every car has a different feeling, right? So every car has a different type of display, every car has a different type of interaction model, and we, as Android Auto, since we're going into many different types of cars, we have to be able to adapt, and that's really tough. So like in this picture, there's a touchscreen. So with touchscreens, we have to make sure that the model is appropriate for tapping and for being able to hit the different targets. But then some cars don't have touchscreens, right? Some cars use the rotary knob. And some cars have other things as well, touchpads, right? So it gets really, really complicated. And we have to be able to adapt. And as you see here, there's just so many options coming into the market today. because everybody is using this as a differentiator for their product. So it gets super complex, and thankfully we have some people dedicated basically to thinking about this, because it takes a lot of thought to try and figure it out.
Yeah, I like to think of it as kind of like responsive design on steroids. But anyway, so obviously, one of the things that Greg mentioned is that for these car so let me just rewind a bit. It'd be really easy for us, right, to say, oh, Android Auto, we need it to interact in the same way for all the different car manufacturers. You should all use touchscreen. And I think that that's exactly the wrong approach, because, the car manufacturers, those differences, those kind of whether they're using a rotary encoder or a touch screen or a touchpad or whatever kind of mechanism it is, that's actually their competitive edge. And it's also part of how they express the character of the cars that they're creating. Cars are an emotional purchase. And I think the worst thing that we could do is just go in and try to homogenize that. So for us, it's really important that we celebrate the differences between these cars and that we make our system responsive so that it can adapt to this competitive landscape. And another thing, I think, so that's kind of one end of the continuum, right? But on the other end of the continuum, when we start thinking about developers, so if we want people to develop for our platform, we have to have some consistency. So if you're going to develop an application today, and I say, well, it's got to work on the touch screen and the rotary encoder and the dial-y thing and this and that, and you're going to have to make a different version for each of it, no developer is going to do that because it's just going to be too expensive and a huge pain to maintain. So we have to create a common platform so that people can create an application once, and then it'll just work in a reasonable way across all of the different types of input and output mechanism that we have to deal with. And that kind of, I suppose, brings us to this kind of idea of responsible, having a responsible design process, right? So how do we kind of think about that? And so we're responsible to the developer for creating a reasonable system that they can develop for. We're responsible to the user to make sure that it's, as we reduce distraction as much as we can. And we're responsible to the car manufacturers to make sure that we put something in their car that they feel, is not going to be damaging or bad for them, right? That they are excited about. So it's actually a very complex space for us to work within. Oh, is it me? Okay, yep. So part of that is that we have this is a very typical slide. How many talks over the next 2 days will have this? Design and research. But I think for us, probably out of any kind of system or product that I've worked on is especially true. And we have to do huge amounts of research, and we have to do huge amounts of design on the tiniest of details. And it has to be highly iterative and work very, very quickly. And quite often we will design things and we find out they just don't work at all, and we just have to be, suck it up. And start again and try different directions. And sometimes it's a matter of just optimizing things more and more and more. And sometimes just from research, we find totally new directions or totally new ways of thinking that we hadn't really encountered before.
Yeah, it's really interesting. So on the research side, when we're talking about designing for an automotive environment, we have to take a lot of things into consideration. So typically, if you're designing an app for the phone, you're really focused heavily on the user experience. And for Android Auto, we also are really engaged in the user experience. But we have to balance that, because on the other side of it, there's human performance limitations. So inside the car, there's some limits at the capacity of what people can reasonably do. And so it's this balance, and it's really, really tough, because you can't necessarily, you can't just throw an app in as is from the phone into the car, because it's just overloading for the user. So we have to go through this painstaking process of figuring out what's the core features, what's the core things that are needed, and then how do we balance that again between having a good experience but also ensuring that it's proper. And so it goes into basically testing everything. So we test, we retest, we test as quickly as we can, as often as we can. So it's basically an ongoing process for each of our features, and then it just cycles back into design. This is, by the way, you'll see in a lot of these pictures, this is Joey. He's our model for all of our slides a lot of the time. So he's a researcher on my team, and we end up making him wear all of our different contraptions, and then we take pictures of him.
Because it was amusing.
Yeah. So here's Joey wearing an eye tracker. Here's Joey wearing occlusion goggles. And so won't touch on the slide too heavily, but basically, depending on the research question that we have or the phase that the feature is in for development, we use different tools to try and answer that question. So in the early phases, that can be heavily qualitative, focusing more on general UX research and figuring out what does the user want or what does the user need or what's the expectations. But then as a feature starts to mature, we need to also loop in the other side of it, that human performance element, to ensure that the feature is actually appropriate for inside the car. So I have, let's see, I hope this works. I have a video. Let's see, how do I set up this video? So there's a YouTube channel called Nat and Low. Is anybody familiar with that by any chance? One hand maybe? Okay.
That's good.
Yeah, so Nat and Low is a YouTube channel. It's a couple Googlers who started this 20% project. So it's a side project. And they decided to go around Google and just highlighting different activities and different things going on at Google. So they have the channel, and each episode is highlighting something else, something different. So they recently went to our lab and did a video for our lab. Unfortunately, they haven't edited that yet. So I was hoping we could actually show the Nat and Low video in today's presentation, but it's not there. So I have instead, as a backup, unedited quick clips from Nat and Low.
The rough cut.
And then you have to listen to me overdub it as opposed to them talking, which is not as exciting. But we're going to try this out. So here's Nat and Low's starting little animation. And then they're going to wave. So there's Nat and Low. Yeah. Okay, so now we're going to talk about some of the different equipment we have. So a driving simulator starting off. So we have a driving simulator at our lab. And we put participants in here all the time, basically. It's much easier and safer to put a participant in a laboratory simulator in a controlled environment than putting somebody on the road. So this is a really great way to get feedback early on by throwing somebody in a realistic environment. So as they drive, we look at the driving performance. We look at different metrics about driving. So their lateral position, their longitudinal position, proximity to obstacles in cars. So all of this is heavy on the data side, but we analyze it to try and get a good feel for how is their driving performance degraded when they're interacting with the Android Auto. We also have an eye tracker, or a couple eye trackers. This is one of ours. And so hopefully, I think everybody's aware, but eye tracking tracks the eye. That's kind of obvious, right? But it's really important for in the car. Because this gives us a quick quantitative measurement for glance durations and glance frequency. So when you're driving, of course we want the eyes on the road, but every time they have to interact, that steals some of that visual attention. So we use this as a way to measure the actual visual attention and the visual demands. And then cognitive. So this is a really, really hard one to measure. And there's a lot of different ways you can do it. Here's one way. It's a very simple way. She's putting it on. It's called DRT, Detection Response Task. And she has a little trigger on her finger. That's what she's putting on. And then there's a tactor. So that tactor on the neck, that vibrates. And it vibrates on a random frequency. And when she feels that vibration, you have to acknowledge it by hitting the switch. And so this black box is the brain, basically, and you're looking at the phase delay between stimulus and response. And so the longer the response, it's an indicator of cognitive distraction. And then these are visual occlusion goggles. This one's pretty quick. They're really awesome. You can see they transition between fully opaque and fully visible. Yeah. And this is a good way, we'll use that as well to look at chunkability of tasks and if the task can, if the driver's able to maintain pace of interaction. So those are some of the tools, a quick glimpse. But again, it all depends on where the product is or the feature is in development, and we pick the right tool for the right phase.
Yeah, so basically we design stuff and then Greg tells us why it's wrong in huge amounts of detail. This is I want to talk about some of its kind of like the implications, and obviously we can't talk about things in too much detail, but I thought we could have touched on them in a hand-wavy kind of way. And obviously we work at Google and we live in Silicon Valley and this is Seattle and we're all thinking about the future and technology all the time. But also we're working within the automotive space. And the automotive space is a space that also has been thinking about the future for a long time. And when they make concept cars and do all this cool stuff. And when you buy a car, I think part of, the thing that you're buying is a little bit of tomorrow today. And one of the other things I think that's really interesting about working within the automotive space from an interaction point of view is that we're working within a defined environment, like a spacesuit, right? So in the car, we know where everything is. We know where the passengers are sitting and where the driver is sitting. We know what their different roles are probably going to be. We know where the handbrake is and the steering wheel and the brakes and accelerators and all of those different things. And that's really, really interesting. So one of the other projects that I've been kind of working on is Android TV. And relative to Android TV, we know nothing. We know that it's a TV, and it's likely that you've put it in the living room. But where is the furniture? What is that TV in relation to everything else in the room? Is it even in the living room? Is it in the kitchen, or is it in the bedroom? We have no idea. And so it becomes very difficult for us to think about things in a realistic way. But when we're thinking about the car, that some things kind of change. It allows us to make some pretty reasonable assumptions and allows us to think about things in perhaps more fascinating ways. So one of those ways is we can start thinking about, beyond the in-cabin UX, right? And there's a horizontal way of thinking about this and a vertical way of thinking about this. And the horizontal way of thinking about this is, what is that journey before I get in the car? And what is that journey after I get out of the car? And we can think about that there are opportunities either side of just the driving experience as well. And you saw in the home screen, it's like Google Now. I mean, that's even kind of starting to hint at that, right? So I get in the car, and if I'd been searching for something on my laptop in my office or at my home before I got in the car, it's likely to come up as a destination when I get into the car. So we can already start to do interesting things there. And then the vertical way of thinking beyond the in-cabin UX is a way of thinking about the interaction and the scales of the interaction that are occurring, right? So you could say that interacting with my phone is one scale, and that interacting with, sorry, it's beeping, go away, the iPhone. And there are other ways of interacting. There are different scales. So there's the car is another scale, but we can also think about what about not just the interacting within the space of the car, but what about the car as a whole? So what is that scale of interaction? So the car can start to interact with infrastructure or the architecture around it. And it sounds kind of like maybe a crazy thing to think about. And believe me, I am not an expert in history of transportation, but I shall hazard a guess, right? And say that when we think about transportation, like any kind of like major change in transportation historically pretty much has had massive impact on infrastructure and architecture. So if we think about all of the building of the railroads, that completely changed the American landscape. Or we can look at, like cars in LA, right? LA was a very different city, and then the cars came along and they put freeways everywhere and completely transformed it into a city that's entirely based around the scale of an automobile. And we can start to see that perhaps similar things will happen. I'm not saying that this is something that Android Auto is going to do this, but I think that we can see that cars are becoming digital entities. And whether it's our solution or a solution from like many of the other companies that are starting to operate within this space, interesting things are going to happen because we can think about applications and services not just existing within the scale of the phone, but existing within the scale of the car. And that's a completely different scale we haven't had the opportunity to think about before. And I think also it says cars are not a solved problem. Sorry, again, the typography's dropped off on the side. But I think that if we perhaps, this slide would have been wrong if we'd shown it perhaps, at the end of the 20th century, right? Perhaps cars were a solved problem. That actually what we were seeing was just iterations on a theme. But now, suddenly, now that we see cars as a digital entity, what does that mean? And I don't think that any of us have any clear answers yet, because we're just at the beginning of this new kind of like domain, which is super, super exciting. And I personally don't think those exciting things will happen until we understand how to think about cars or cars as digital entities as things unto themselves. So that sounds like a strange thing to say. But when we think about, for example, the transition from a PC, the PC era to the mobile handset, right? There was an interesting thing that happened at the beginning. People said, oh, I have a PC and I understand how this thing works and all the patterns that are involved. Let me squeeze it into a little phone. And that didn't work out very well at all. And there's plenty of phones that we can see in the graveyard of the past where they didn't really work very well at all. And it's only as we understood what an appropriate level of interaction was, what an appropriate service was, what an appropriate kind of way of thinking about this and modeling this space was. That's really when this space kind of exploded. And I think that's exactly the same thing that's going to happen with cars as digital entities. And of course, a lot of the people are basically going to say, oh, well, I can just take all of the learnings I've got from my phone and squeeze it into a car. But I think that actually we've kind of realized that that's not true at all, and that we need a completely new model moving forward. So that kind of brings us back to this idea of what is designed for driving, right? And it's not just kind of thinking about distraction, and it's not just thinking about what kind of things are appropriate to put in the car, but it's also thinking about what kind of potentials we can create for tomorrow. So I think it's probably our time up. So with that, I'm not sure if you have any time for any questions. We've got 3 minutes. So maybe time for one question.
Yeah. I think you had your hand up first. Yeah, go for it.
So what is, are there any links like between the Android Auto and this autonomous vehicles tool?
Okay, so that's an often asked question.
Repeat the question.
Yeah, I'll
just
repeat the
for
question.
video, yeah.
Are there any links between the Google self-driving car and Android Auto? There are no links. They're very separate projects. Actually, we are Google, and self-driving car is part of X, so they're even separate companies. So, yeah.
Are there any learnings which are like important, like for both projects? You can learn from some of the self-driving car interfaces as well, like when designing for not self-driving cars.
Yeah,
I think that there probably are learnings, but we just don't interact, at all. Yeah. How do we view our work in the context? That's a good question. So how do we view Android Auto in relative to self-driving? And I think that, one of the things that we talked about is we said, everything that we're dealing with is all organized around ideas of distraction, right? So when there is no distraction, when the car's driving itself, what does that mean?
yeah.
Oh my gosh, and then we kind of realize, well, actually, maybe it doesn't mean that much, because actually, we're not just thinking about distraction, we're thinking about the scale of interaction at the car level. And actually, pretty much, I think that when people are in a self-driving car, they're going to still want to know where they're going, they're still going to want to listen to music, and they're still going to want access to those other applications and services that exist within the scale of that domain. And maybe they will be afforded a more complex UI, right? Because we can't give them that, because that's not responsible. Right. But I think that many of the things that we're thinking about will still hold true.
Yeah, in the back.
I'm just curious if you guys have tested out scenarios for after a crash has happened, if that's part of what we do, or
Good question.
whether it transmits, the way some emergency systems transmit.
Yeah, okay, I see. So the question is, have we thought about post-crash type of scenarios? We have thought about this, yeah. So it's things that we're thinking about. It's currently not in any of our products or anything like that, but it's things that have been, there's a lot of things that we have on the discussion table, and that is one of the topics, yeah.
Yeah.
Sorry, I think you were next, yeah.
So, well, I like the UI and what triggers, something like that. So how do you deal with taxing, like more complicated?
Oh, that's a great question.
Texting.
Yeah, okay.
Yeah.
So, so texting, that's one of the big drivers of Android Auto, is to try and, find a new way so that people don't have to actually type out text on their phone, because that's obviously a big problem in the world, the US and the world collectively. So in our model, we do have messaging services in Android Auto, but they're purely voice-driven. So you can get notifications that a new message has arrived, but it will speak it out to you. And you can have the option to dictate a message through voice.
Also for calling.
For calling, yeah. So we have a phone area in the app where you can select people to call, like your favorites or your recents. But then instead of having your full phone book, you can use voice and you can say call whoever, and then it will place a call.
And is this allowed by laws? Since, as far as I know, in California, calling during driving is
Calling is okay. So you get into, like, there are differences in legislative behaviors definitely throughout the world. But typically hands-free calling is okay. It's when you get into handheld calling that you get into problems.
Yeah, maybe one thing, I'll just rewind really quickly. There was one of the things maybe I didn't explain like very well is that when we're here, when we see this kind of slide, right, when we're in this mode, the phone is actually locked out. So we want to encourage people to use the system or the interface that's appropriate for driving, and we don't want them, if possible, to be using their phones.
Mm-hmm. Let's see, I think you were next.
Have you found any pros of adding haptic feedback, like sort of to tell like that action actually went through, like
It's-
or died last time?
Yeah. So, yeah, that's a really interesting question. It's whether or not we've looked at haptic feedback as another additive for help building the kind of the understanding of the model. I mean, we've considered it. I think the issue is that ultimately we inherit whatever is in the car already today. So if the OEM has that as an option, it's something that we look into, but it's, until the auto manufacturers actually put it into the car, we don't really have a mechanism to put it in. Does that make sense? Yeah. Let's see, somebody else, you had a question.
You mentioned
Hopefully
that
right.
when it's connected and the phone is locked out. Have you explored dual player modes where you have a passenger who wants to choose?
Yes, we have, and I would just say probably those are still under exploration.
Mhm.
Yeah.
Sure. I think one last one. Yeah, go for it.
Is there a significant difference between physical buttons and glass buttons?
That's a really interesting question. So the question is if you see a significant difference between physical buttons and glass, like touchscreen buttons. I mean, from the OEM industry, typically you do get a quicker, a reduced glance behavior when you have a physical button because you have the added tactile feedback that, if I'm in a dark environment, or if I'm just driving environment in general, I can bring my hand over and I can feel around until I find that button. And a lot of the design inside the car is actually really intelligent. They'll have one, if I have 5 buttons, the middle button has a little indent or some sort of marker so that I can feel the middle button and then I can easily navigate my way from there. So there's a lot of greatness to having that tactile feedback for the physical buttons. The difficulty with the physical buttons is it doesn't give you the affordance for a dynamic environment. So those buttons are often set, to one task. Whereas, in today's cabins, a lot of time things are constantly changing, or there's so many options available.
I'd say also things like, for example, the difference between a touchscreen service and using a rotary encoder is that when you're using a rotary encoder, it tends to bias the system to wanting more states and more levels of hierarchy, right? I'm scrolling down into this list, I'm coming back out of this list, and it gives you kind of, again, less flexibility.
Yeah.
So there are pros and cons.
Yeah.
I think that's it.
Okay, I think we're past time. Thank you guys very much.